All right, welcome back and good day to Everything Mathematics. And today we're going to continue our series of geometry. Today will be our second video. We would have started yesterday looking at the concept of geometry. And today we're going to look at another concept of plane shapes. And I don't know, I guess it's just my style of teaching mathematics. But one of the things I like to do before going into any working, any content, any whatever, I think it's always best and easy. In fact, that's one of the ways I was taught that you understand what it entails, what the concept, what the main idea, what the big picture is before we delve into some working. So I know maybe the average teacher, the average person, when they hear plane shapes, they start talking area, perimeter, finding the area of a triangle, the area. And yes, those things are true. Those things are part of plane shapes. But I think it's easier when we understand what a plane shape is all about. And then, of course, I think the rest comes easy. So what are we going to do today? Of course, look at the concept. So we're going to be defining what is a plane shape, and then we're going to look into some examples of a plane shape. So we're not going to be doing any arithmetics or anything like that today either, unfortunately. Yesterday we did a lot of talking in defining the concept and looking at geometry. And today again we'll be doing a lot of concept, another concept. And hopefully in the next video tomorrow, God's willing, we might just have some working to do. Might. Let's see how it goes. So, what is a plane shape? Simple. A plane shape is a flat, two-dimensional, bounded figure. That is what a plane shape is. So oftentimes when we tell students, give me an example of a plane shape, often no, not even give me an example. In class, I could tell you from my experience, I would ask students, what is a plane shape? And here the answers I would normally get. A triangle, a circle, a square, a rectangle, a rhombus. Yes, all those are plane shapes, but that does not define a plane shape. A plane shape as defined in front of us, and then we could see all these relationships with the triangle. A plane shape is a flat, so yes, a triangle is flat, a square is flat, a rhombus is flat, rectangle are flat, and parallelograms are flat. Two-dimensional. Yes, all those shapes are also two-dimensional. They are measured by simply having a length, and a width, or width and height, or length and width, however you call it. That is two-dimensional. There is not a three-dimensional. There is no depth. There is no depth in a flat surface. So that is why it's called 2D. So when you think about 2D, you could think of this is 2D, this is 2D, this is 2D. No, this is not flat, it's closed, right? So that's 2D. So we understand it 2D. So we're not just saying it because, but it has to be. And another thing that throws off a lot of students, bounded. It must be bounded. So if I have something like this is not a plane shape. It might look like a triangle. It might look like I was going and draw a triangle, but ideally, this would not fall under the category of a plane shape because it is not closed. It is not bounded. I might look like I'm going to draw a circle here, but guess what? There is a gap. And as long as it is not closed, it is not a plane shape. It might be something else, but not a plane shape. And that's one thing we need to understand. If I have this, that's not a plane shape. It's not a plane shape. It might be flat, it might be 2D, but it is not closed. And these three things must be true if I must put it like that. By the way, two-dimensional, another way to say two-dimensional, as I just mentioned, there is 2D. Yes, so these three things must be true in order for us to have a plane shape. So if I have my rectangle, my triangle here, for example, these three things must be true. Is it flat? Yes. Is it 2D? Yes. Only depth and height, height and depth, width and length, whatever. Is it closed? Yes. No open spaces, no gaps. Yes. So that's 2D. And moving on, another thing that we need to note, and this is something that has confused a lot of students, even some of us teachers, but a plane shape can only be represented on a drawing, on a paper. Only so. We cannot hold it, we cannot touch it, we cannot what? carry it from one place to another. Yeah, maybe unless you bring it on your page. But in real life, you cannot hold, or you cannot, or should I say, let's just say a plane shape is something that you could only represent on paper. And when I asked my students this, I remember a particular year, I brought a paper on the class. I brought a piece of paper, a page. You might call it a page. And I asked the students, what is this? And everybody in the class said, every single person, sir, that is a rectangle. And I told them no. And it's like, nobody realized why I said no. I said, no, guys, this is not a rectangle. Think about it. And then they start thinking. And one person eventually said, oh, of course, I give them hints. I was giving them clues and so on. I was giving them, tips. And one of them ended up saying eventually, so that page is a cuboid. A cuboid. And then I said, I'm spelling cuboid. I think it's a D. I don't know. You're looking funny. Anyway, it don't matter. Cuboid, I want to write it. Right. And then I said, yes, you're correct. And then some of them started to realize, even though a page looks flat, it actually has thickness. Yes, as thin as it is, there is thickness. So that disqualifies it as a plane shape, because a plane shape must be flat. Remember, length, height, width, height, no depth. If it has depth, as slim as the depth might be, it will not be a plane shape. And from that day, believe me, I believe I opened a lot of my students' eyes in that class. One of them went as far as relating to me, so sir, all them papers the teacher in primary school hang up in the class, they're not plane shapes. And I had to tell that child, you are correct. So then I went on and I asked, so what was the circle? And they shouted out, a cylinder. What was the triangle? They said, sir, a triangular prism. So what was the square? And they say, so a cuboid or a cube and or whatever. And they keep going on and on because they understood the concept. And that is one of the things we need to understand. So this made a lot of their life easier when we started calculating areas and perimeter. And when we reached solids, they appreciated it even more because then they realized, okay, a solid has depth. So it's length by width by height to calculate volumes and so forth. And that is what happens when we understand the concept and not just calculating widely, if I should put it like that, for lack of a better word. Right? So that's one thing we need to do. Let's now look at some examples of plane shapes, and that should be the end of today's video. So commonly, of course, I know we know a few. So we have triangles. Triangles are examples of plane shapes, and mind you, under triangles we have subheadings. So we will have the scalene, the equilateral, the isosceles, acute angle, right angle, obtuse angle. So there are many types of triangles, and we're going to be, I think it's sometime this week or maybe by next week, I'm not sure, we're going to be addressing the various types of triangles. Then of course we have quadrilaterals, and when we talk about quadrilaterals, you know we talk about four-sided figures. So we have our square, our rhombus, parallelogram, our kite, and the list goes on the line. We have quite a few of them, right? And again, we're going to be addressing that in upcoming videos. We're going to look at all the features, all the properties, all the characteristics, which is what really qualifies a shape. And yes, of course, we're going to be looking at some arithmetic too, because we need to be able to work out some of these concepts. I think we're going to be starting with triangles this week, and quadrilaterals will come sometime next week. Let's go. We have any regular and regular polygon. Good. And we need to understand that a polygon is a shape that has, well, I think I define it later, so let me not jump the gun. I'll define it lower now. So any regular and regular polygon, and of course circles. Circles fall in a bracket of themselves because circles don't really have sides. Well, I mean, of course, if you know how a circle shape, this is a circle on a sketch. And circles don't really have a side like a triangle would, or like a square or quadrilateral would, a rhombus. They don't have sides. So they are a special group of their own. They fall in a special group of their own, but it is a flat plane figure. Because at the end of the day, we could only represent a circle in drawing. We cannot graph it, we cannot touch it, we cannot, whatever. It's a drawing. Only in drawing we could represent it. And the minute we cut out this paper, let's suppose we have a piece of paper here, and the minute we cut out this circle shape, we no longer have a circle. Instead, we actually created a cylinder, because this will have some depth. As slim as it will be, it will have some depth. It wouldn't be flat. And I remember, as I said that to one of my students, justify the reason why paper could cut you. And I said, yes, you are very right. The reason a paper edge could cut you is because there is some measure of thickness. Whether, however sharp it is or whatever, yes, paper can cut you. And I hope that's common knowledge to us listening here. And I was defining a polygon earlier, and here we have a polygon. So a polygon is basically a two-dimensional figure or shape formed by three or more sides, well, straight sides. So that's basically a polygon. So when it comes to certain polygons, and I'm going back to number 3, just before I wrap up, you have to understand that not all polygons are regular. Some are irregular. And by regular, by the way, if I must be clear, a regular polygon is any polygon whose amount of sides and angles are the same. So for example, a square. A square is a regular polygon because all sides are equal and likewise all the angles. And I hope that I use square because I think everybody should know what is a square. But there are many other regular polygons that have equal sides and equal set of angles. We're going to look at them later down the line. I show right now probably a few popping up in your head because they're pretty common. But then you also have regular shapes that are, you also have polygons that are irregular. For example, this, okay, let me draw it neater. I'm just trying to draw something stupid, it don't matter. This is a flat shape, like it or not. It may not have a name. Actually, it does have a name. You just have to count how many sides. So this is actually a 1, 2, 3, 4, 5. Okay, I started counting here. So 1, 2, 3, 4, 5, 6, 7, 8. So this is actually an octagon. Believe it or not, it is an octagon. And I know maybe when we think of an octagon, we think of something like this. Or this, you go up so, you go down so. I think that 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So maybe when we think about an octagon, this is the shape that we think about, an 8-sided figure. But no, an octagon is an 8-sided shape. This one up here is what we gonna know to be a regular octagon. Because guess what? All the sides and all the angles will be equal. But this here is also an octagon because it has 8 sides. But it is irregular because of course all the sides are not equal and all the angles are not equal. So like clearly, for example, you could see that here is a 90 degrees. But somewhere here, we don't know the angle, but we know it's an acute. And as we know, an acute is less than 90 degrees. That's an acute angle. This angle here kind of look obtuse. It looks like an obtuse. And an obtuse angle will be an angle that is greater than 90 degrees, but as you know, less than 180. So yeah, so that's basically one of the things that you need to understand about these shapes and them. But don't worry, again, as always, I give you my word as we go down deeper into geometry. Right now, I'm just setting the foundation. I'm just trying to set a foundation. So we're going to springboard on that foundation. So that will bring us to the end of today's video. And again, as always, like, share, and subscribe if you haven't done so as yet. Share it with your friend. Tell somebody who you like, or tell somebody who you know is doing maths, or just somebody who would like to learn maths freely, if you want to put it like that, so that they can subscribe and follow up with all the basic information I'll be sharing in maths, and of course, build up from there. So until then, you take care and see you in the next one tomorrow, God's willing, where I believe we're going to start dealing with some arithmetic and go outside of the content. So until then, you take care.